Hello, my name is chouaib. I'm from Algeria, architect student, local university, PhD. I graduated with a Bachelor of Architecture from University Tari Mohammed Bishar and Master degree from ISO Oran in Algeria. I have 18 years of experience in the field of architecture with very large number of projects realized, new construction and restoration and rehabilitation. Our subject today is the explanation and comparison between different traditional underground water systems. Human demand on the world available freshwater supplies continues to grow as the global population increases in the endeavor to manage water to meet human needs. The needs of fresh water, space, and ecosystem have largely been neglected, and ecological consequences have been tragic. Healthy freshwater ecosystem provide a lot of goods and service for society, but our appropriation of freshwater flow must be better managed if we hope to sustain these benefits and freshwater biodiversity. The Fogara systems consists of an underground tunnel that conveys water by gravity from a highland aquifer to the ground surface at lower elevation. Blended with the ingenuity is proposed is simply to collect and bring underground water to the surface for use. The Fogaras considered hydraulic engineering system of an old world providing water to settlement. Since its invention, the Fogara have helped to transform area behind this sustainable water source system was passed from one generation to the next and traversed the geographic boundaries. This system used in different countries like Iran, Syria, Turkey is not confined to one place and has been adopted in many regions across the world. Our question is, what is the difference between the different systems? In the first, I will give the definition of XR. In Algeria has a vernacular architectural heritage of recognized value which constitute an indissoluble parts of its cultural legacy. XOR, singular XR, the fortified cities in the Sahara of North Africa located along of the historical communication road which for millennia have allowed trade between the North Africa and Sub-Saharan. The west of Algeria, especially in the Sahara, was historically difficult in the region group the main south from according this culture and built works Ksar house and Fogara which embodied aim alive in this area. The shape that emerged allowed adaptation to hostile environment and most importantly domestication of territory. Therefore, to survive in this harsh environment, the Oasis farmer have developed especially a method that get used the local condition. These are the Fogara, subject of permanent struggle, which have down this genius to guarantee life in this desired region faced to very fleeting rainfall, high temperature, height, wind. The Fogara definition: the Fogara is an underground tunnel on the 100 meters long, equipped with several air shafts for maintenance and ventilation of the gallery to ensure the gravity flow. The gallery is slightly inclined. The length of the gallery range from 100 to 14,000, like in figure 1 and B, A, B, C. The number of Irish walls vary from 10 to 500, with the depth engineering from 8 meters to 14 meters. The second example is Roman aqueduct definition. An aqueduct is a channel or pipeline to transport water over a great distance from water source to its destination. Often a city, sometimes a farm, a factory or mill. There, the water is distributed. The third example is the canal definition. A canal is a combination of a filtration, a gallery or mother that collects water from an aquifer and underground tunnel, connected series of vertical shafts to transport water by gravity to the surface for direct consumption and or irrigation. In the canal, basic element have mother wall and access to shaft and canal channel here, and outlet of canal and distribution water in the tunnel. That water is then transported where the water leaves the tunnel, and in its an open canal is called the outlet or drago mount. This is an example of the canal region in China. Machu Picchu example is the last example of underground water. The city of Machu Picchu owns the royal estate of the powerful Inca emperor, lay hidden in the mountain of Peru until the 1911. When Iram became a professor of history at Yale, discovered its ruin. Since then it has become perhaps the most important archaeological site in the Americas. Most people know Machu Picchu not for its history, but for its breathtaking beauty, like you see in photos. For years, few, even with the scientific community, recognize that also represents remarkable achievement of civil engineering. The fountains of Machu Picchu, the canal descend the mountain slope until the city was passed through the archaeological sector, then cross the inner wall into the urban sector, where it feeds city of 16 fountains now as story of fountains. The fountains are publicly accessible and partially enclosed by walls that are typically about 1.2 meters height, except for last fountain, which is a private fountain for the temple of the Condor, and has higher walls. And the last is the comparison with the physical geography, the comparison between these 8 systems and by the element characteristics, by the physical element, like characteristic of the terrain, climate, source, type of source, place in the landscape. The second comparison is technology with the element of construction, builders, cars, a work of art, distribution, storage, and surplus waters. The third comparison is societal, is between this element, user, ownership, and finance and status within society, present status. In the conclusion, adjacent to a mountain watershed to create a large was on the otherwise take environment. Many canat and fogara are still in use, stretching from China and Algeria and even to the America. The irrigation system is one of the most important sources of drinking and farming water in many countries, even though there exists spatial data about the tunnel. There is need to an up-to-date database system that manages this data. This is necessary for researchers, the local government, and the inhabitants of this region. Traditional irrigation systems have been in rapid decline, displaced by pumping wells over the last half century, which mainly resulted from the disadvantage in using a traditional irrigation system to augment the water supply for large-scale irrigation when compared the modern irrigation technology. The many face a fate of disappearance in the near future, which is a scenario that is being played out in Iran, Afghanistan, Pakistan, Syria, and many other places. There, Fogara Kanat Karas are still in use. Arid areas should not be underestimated. It is of no sense to debate over whether all the existing traditional irrigation system should be restored and rehabilitated, and it is not wise to slowly depend on ancient solutions to meet today enormous water demand as a cultural heritage and ecologically friendly engineering creation. However, this system shall be kept in good condition and function by variable